Hello, today I'm going to be walking you through the 2016 December Contest Bronze Problem 2 block game. Farmer John is trying to teach his cows how to spell using blocks. Each block has two sides, each with a word of length n, and we are trying to find the minimum number of letters, of little block letters, so that we can spell every single word no matter what combination. So my so we can so we have our blocks: fox, box, dog, cat, car, bus. And let's look at this first block right here. So a block, can imagine it like this. Our block is like this. Our block is like this, and we have two sides, and so this side says box and the other side says fox, and we can flip it either way. So we can look at these two words, and we can see, only one of these sides can be on at a time, and so no matter, and so we only need an F, a B, one O, and an X. Because no matter, so if we were to, there's only two possible combinations for this single block. It would be either fox is facing up, fox is the side that's facing, or box. And we have enough letters to spell both of them. And so my solution just goes through each of these lines, and it calculates the number of similar letters. And if, let's say, a word is Fuchs and box, and this one has two more O's, we would add the one with two more O's to our outputs. So here's my code. Initialize our scanner, print our output, and this alf is our counts for each variable, or each letter, I'm sorry, and we have our n, and we just go through each block in the input and we calculate it from there. First, second, the fox and box, dog, cat, and then we have our hash map, which stores the number of times a letter or string appears corresponding to, so this is right here is the letter. So we have F, so let's say we're looking at fox and box. This M1 will be corresponding with word 1, word 2, and so we have in our hash map F1, O1, X1, and then B1, O1, X1 for the second one. And yeah, so then we just calculate that here. Then we have a scene hash set, and now we're going to be counting the common letters, and so we count common letters for our word 1, and so if we haven't already counted this letter, then we see if the other word contains this letter. If it does, we get the amount of times it's been seen, and if this amount is greater than the amount of times, so we would have, so let's say if it's Fuchs and box, so let's have two cases and box, or sorry, fox and Fuchs. So these are two cases, and so you can see that this is 2 and this is 1, and so our code would check the amount of the amount of times this certain letter, we're looking at O right now, and so our map would have O2, O1 would be the first map, and we would just compare this number with this number if, of course, this second letter contains, this second word, contains the letter we're looking at currently, and if it is greater, then we just get this value inside. We get the corresponding element in this array and increase the amount that we need. And then if it's not contained, and then we just add it that we've seen it. And then we do the same for the second word. Do the same thing for the second word. And that is the solution. 10 out of 10 test cases.